Students, welcome to the channel. The topic is simple harmonic motion. What is simple harmonic motion? It is a special type of vibratory motion. You know vibratory motion? The motion in which a body moves back and forth about a fixed point is known as vibratory motion. And simple harmonic motion is a special type of that vibratory motion if it satisfies these two conditions. What are these two conditions? Number one, the acceleration of vibrating body is directly proportional to its displacement from the mean position. Number one is this condition, and second is that its acceleration is directed towards the mean position. So any vibrating body that satisfies these two conditions, its motion is called simple harmonic motion. For a body to perform simple harmonic motion, there are two requirements. Number one, there should be a restoring force. It is a force that brings a body back towards its mean position, and there should be inertia. So these are the two requirements for a body to perform simple harmonic motion. Now students, let us consider different bodies which are in vibratory motion. For example, a metal strip that is fixed at one end, and when it is disturbed, it will start oscillating about mean position. O is the mean position, A and B are the extreme positions. Similarly, when a pendulum bob is disturbed from its mean position, it also performs vibratory motion. And third is the mass attached to a spring. When this mass is disturbed from the mean position, it will start oscillating. The surface is frictionless. So all these are the examples of vibratory motion. Are they simple harmonic motion or not? If they satisfy these two conditions, that is the mathematical form of those two conditions, which shows that acceleration of a body should directly proportional to x. X is the displacement from the mean position, and negative sign shows that this acceleration should be directed towards the mean position. Student, it means that the body slows down while moving away from the mean position and speeds up while moving towards the mean position. This is how its acceleration is directed towards the mean position. Again, two things are important. One is the inertia, another is the elasticity. Look at these examples. When this bob of pendulum is disturbed from the mean position, and if we take it to the extreme position here, and when we leave it here, it will start moving toward the mean position. Which thing brings it back toward the mean position? That is called elastic restoring force. And that elasticity or elastic restoring force brings it back. And it does not stop at the mean position due to inertia. So a body performing simple harmonic motion must have elasticity and inertia. So if a body fulfills all these two conditions, such a body is in the state of simple harmonic motion. Now students, there are special terms that we use in this context. That is the terms used in simple harmonic motion. Let us consider the example of bob of a pendulum. When it is disturbed, it will start oscillating about mean position, and it is performing simple harmonic motion. Now what are these terms? Number one, mean position. In case of simple harmonic motion or vibratory motion, here is the equilibrium point. When a body becomes at rest finally, this is its equilibrium position. So when a body is disturbed from this position, it is the point about which the body oscillates. This mean position is called, this point is called mean position. Second is extreme position. Here are the points from where the vibrating body returns towards the mean position. Those points are called extreme position. There are 2 points, one on each side of the mean position. Next term that we use is vibration or cycle. In one complete round trip of a vibrating body is called its vibration or cycle. Means if this bob starts from here, and after completing one round, when it returns here, we say that it has completed one cycle or one vibration. One complete round trip of a vibrating body is called one cycle or one vibration. Next is the time period. That is another important term that we use in the context of simple harmonic motion. It is the time required by vibrating body to complete its one cycle or one vibration. That time is called time period. Next term is frequency. How many vibrations or how many cycles are completed in 1 second? That is called frequency of the vibrating body. Students, frequency is represented by F and time period is denoted by T. Frequency and time period are reciprocal of each other. Higher the frequency, less will be the time period. Quickly, the body will complete its vibration. Frequency is high, time period is low. They are reciprocal of each other. Increasing time period decreases frequency and decreasing time period increases frequency. Next is displacement. During vibration of a vibrating body, its displacement is the distance from mean position at any time. It can be 0 when it is in mean position, and it can be maximum when it is at extreme position. And this maximum displacement on either side of mean position is called amplitude. So amplitude is the extreme distance from either side on either side of the mean position, and displacement is the distance at any time during its vibration. Minimum displacement will be 0 and maximum displacement will equal to amplitude. So we can also say that the maximum displacement on either side of mean position is called amplitude. Students, these are the terms that we use in simple harmonic motion. I hope it is clear. Students, thank you for sparing your time to watch this video. If you liked the video, don't forget to subscribe the channel. Take care of you. Goodbye.